Welcome everyone to this session on Python programming for data science. In today's session, we'll see how to go about importing data from an external source into Python environment, exporting the data to an external source, saving, loading, and certain data manipulation activities. So let's get started with data import and export. There are certain files which I have provided. You can download it from the e-learning portal. There are 3 files. The files are named as lr_ds1.csv, lr_fixed-width format, and lr_xls.xlsx. LR is actually stands for logistic regression. Eventually, we will work on these files, create a data set, and build a logistic regression model. So that's why the word LR. Otherwise, it's a dataset 1 and fixed width format FWF, and XLS, as the name suggests, it's an Excel file. Okay. Step 1, we import the 3 important packages: Pandas, NumPy, OS. Shift enter. The 3 files which I just mentioned, these 3 files are stored in my laptop in this path. So what I'm doing is I'm changing the directory. OS is operating system, change dir. In case I don't run this syntax, in that case, if I have to import the file, I'll have to give the full folder path along with the file name. However, what I'm going to do is I'm going to change my directory, and having changed the directory, if I now want to read a file, the first thing what we'll read is lrds1.csv. CSV, as the file extension suggests, is a comma separated value file. Let me open this file and show it to you so that you better understand what is the content of this file. Okay, I have opened the file in Notepad. I have intentionally opened it in a Notepad. By default, if you're working on your laptop and you have got Microsoft Excel, if you double click on the CSV file, it will get opened in Excel. But I wanted to show you the format of a CSV file. You can see the first row of the file has got column headers, and the column headers are separated by comma. So the first column is cust ID, the second is target, the third is age, then gender, and so forth. And here are the rows. The first row has got cust ID as C1, target value is 0, age is 30, male, M, and so forth. The values are there. So basically, this is one of the most used file format, which we call it as a comma separated value file format. We are going to import this file. I'm going to close it off. Now, how do we import a CSV file? The syntax is very simple. Pandas package has a function read_CSV. We simply call pd.read_CSV, give the file name. This step will read the file, and here I am importing and giving it a variable name as lr_df1. The resultant object will be a data frame, and that data frame has been assigned a name lr_df1. I want to see initial few records. There is a command head. If you run the head command, it will show you the initial 5 records. So let's get executing the code. Control enter. Yeah. So here you go, your file is imported. In case I want to see the bottom 5 records, I can run the command tail. So this gives me the bottom 5 records. So here is the syntax. Kindly execute the code. We have just imported the file. I would like to know how many records are there and how many columns. So we have got an attribute called shape. If I run shape, it gives me output 20,000, 8. 20,000 is number of rows, 8 is number of columns. I want to have a more descriptive information of this object. There is a function called info. Now here there is a function. This is an attribute. Please note, when we run an attribute, we don't put brackets. And when it's a function, we put brackets. So if I want to have more detailed information, I write a function info. And this info tells me, okay, the object is of type DataFrame. The index, there are 20,000 rows with index from 0 to 19,999. There are columns. In all 8 columns are there. And the first column is cust ID, target, and so forth. Note, cust ID is having values which are string values. String values, the data type is shown as object. Target has got values as 0, 1, it is shown as int. And balance has got values with decimals, the data type is shown as float 64. So the point I'm trying to say is, if a column has got string values, the column data type will come as object. Don't expect it to come as string. Okay, in Python they have given data type of string as object. Okay, so finally it summarizes, float 64 there is 1 column, int 64 there are 3 columns, and object, that is string columns, there are 4. Total memory usage is around 1.2 MB. So that's a basic information. In our last session, we learned how to go about referencing columns. The first syntax, I am referring the cust ID column. However, I always prefer not to refer columns using dot data frame dot column name. I avoid using this because this syntax is very similar to the syntax of shape. Now when I use shape, shape here is an attribute, and here I'm trying to refer a cust ID with a similar syntax. It will work. There is no doubt that the syntax is going to give the output, but I always prefer using this kind of a syntax if I want to refer a column, data frame name, rectangular bracket, in single quote or double quote, you put the column name. In case you want to refer multiple columns, you can put the multiple columns into rectangular brackets. Then you have iloc. Iloc is index location. So here at row position, I'm not putting anything. I'm simply putting colon. Colon means all rows. And at column position, I'm putting 0, which means I want the 0th column index. Then there is lock. Lock is you refer columns by their label names. Here I'm saying that first to 10th rows is what I want, and the first column. These are multiple ways of referring cells, rows, columns in Python. All of that was done in detail in our Pandas package section. So I just quickly put here those syntaxes. Because I have written these all syntaxes one after another, the output of the last syntax is only going to come up on the screen. Okay. So let me just run Control Enter. In case you want to try out each and every of them, you can copy and individually paste in each cell and run one by one. Okay. Now there are various options which we can use while importing. In our data file which I showed, the first row had the header. Just imagine you have got a data file where headers are not given. So what I'm doing is I'm using option skip rows equal to 1. So I'm saying the first row of the file, you skip it. The moment I skip the first row of my file, header is gone. which means header equal to none. If I use this options, just I'm simulating. Here please note, because my file has header, I'm trying to simulate and explain what happens if header is not there. To simulate that scenario, I'm saying skip rows equal to 1. As a result, what will happen? Header is gone. So I'm saying header is none. If I have this kind of data and I import, the column index positions becomes the column names. Now, ideally, you should not give column names starting with number. But in this case, automatically the column index positions has become column names. What I can do is I can add one more option saying prefix. If I use the prefix option, my columns becomes x0, x1, x2 and so forth. However, typically if you get a data from your client and column headers are not there, as a procedure, we would obviously ask, kindly give me the column names. Assume the client has given the column names. In that case, you can yourself give the column names. So here is the final syntax where I have the file which I am importing. Header is none because I'm skipping the first row. How do I myself assign the column names? I assign the column names saying names equal to, and whatever column names are there, you put it in a rectangular bracket. I'm using a rectangular bracket. It means it is a list. Prefix. Now, if you are supplying the column names, the prefix option will be ignored. I execute the code, and when I execute the code, you see none of the column name has got a prefix. So if you are explicitly giving the column names, the prefix option is of no use. So this is how you typically import a data file where header is not available. I am now explaining one more option. Now before I explain one more option, how many options are there? If I want to know what all parameters this read underscore CSV file can take, what I can do is, I'm just trying to explain, I can have pd.read underscore CSV bracket open, shift tab. I'm pressing the keys. What I have pressed, I'm just typing here in comment, shift plus tab. My cursor is somewhere here in this bracket. I press shift tab, a help documentation opens up, and I press this plus button. Oh, it's gone. Let me try once again. Yeah, I press the plus button, it opens up. So there are so many parameters, arguments, which this read underscore CSV function can take. However, depending upon our requirement, we'll have to see which parameter is of importance. The most important parameters I have already used: skip rows, header, names, prefix. And here I'm trying to explain one more parameter, which is called converter. The converter option helps you do some data transformation at the time of import only. For example, I want to do some data transformation. Here I'm taking a very simple example of data transformation. Occupation, if you see the data which we imported, occupation is all in capital. Just assume a scenario where the occupation values are in mixed case. Some values are small case, some values are capital case, and the data is not in a proper case. In that case, I want data to be converted, say, in a all uppercase or lowercase. So what I'm doing is I'm using a parameter converter. Converter equal to. Now in converter, I'm making use of curly braces. Curly braces is for dictionary. So here I am specifying the column on which column I want certain transformation to be applied. So I say on occupation, that is become my key. Now this key, that is this column occupation, I am passing to a lambda function. Lambda function, as we know, is an anonymous function. It gets created and destroyed at runtime. When the code is getting executed, at that point the function is created and it gets deleted. The function is not permanent. So here lambda function, this occupation column is now represented by the character x. What transformation I want? I want x to be converted to lowercase. So I say x dot lower. So this is how I can do certain data transformation at runtime itself. If I want more conversions, I can put comma. I can say age. Assume I want to do something on age. I can say lambda y colon, and now here y is representing age, y plus 10. In that case, what will happen? All age values will be incremented by 10. So on any column you want to do any transformation, you can use this converter. At the runtime itself, at the import time itself, the conversion will happen. Control enter. Oh, sorry, what happened? Okay, the error has occurred because of this line which I have written at top. Let me delete this. Now let's execute this. Control enter. Yeah. Now here the data has got imported and all the values have converted to lowercase. Okay, we have just seen how to go about importing a CSV file. Let me just scroll back to top here. In Python, you can import data from many external sources. We have seen how to import from a CSV file. Similarly, you can import data from a fixed width format. You can import data from an Excel format. You can import a data set which is of SAS. SAS is a proprietary tool of SAS Institute, and it is most used in many of the banks, and it is one of the leading player in statistical software. It means here Python. Python can import a data set which is in a SAS format. Python can connect to database and import data from a database. So Python has given you many features by which you can connect to external data source and import data into a Python format. Okay. Having imported data, there is obviously a requirement to save that data. Now just imagine we imported a file lrds1.csv, which was a CSV file on our hard disk. Using pandas read underscore CSV syntax, we imported that data. Where has that object created? That object is created in our memory. I shut down my Jupyter notebook, and next day I come back to work. Where will that object be? The moment I shut down, all objects which were in memory are gone, which means I have to restart my work, typing all of this, executing, not typing, but I'll still have to execute. Probably you might have done lots of data management, data manipulation activities. You do not wish to keep running the syntax again and again. You want to continue from where you stopped. So what it means is you want to save certain of your objects to hard disk such that you can load them the next time you open the session. So what I'm going to quickly show is how to import Excel file. I'll execute those syntaxes. Here there is an Excel file. Here there is a command pandas.excel file, and you can provide the file name which you want to import. In that Excel, how many sheets are there? When we talk of Excel, we say Excel is a workbook, and in that workbook there can be many worksheets. So from this workbook, which is lrxls.xlsx, I want to know what are the sheets. So if I run this syntax, it will list all the sheets. The file which I have provided has only one sheet, and I can then import using excel.parse, and I specify the sheet name, and this is how it gets imported. There's another file which I provided, which is a fixed width format. Let me also run the syntax of fixed width format. Here note, it is pandas.read fwf f fixed w width f format. Let me just quickly show you the fixed width format which I have provided you. Let me open it in a WordPad. I have opened the fixed width format file in WordPad. Ignore the first row which has got the header, ignore it. But now just focus on this row, C1826. Here C1 is the customer ID, and then there is space. This is the first space, second, third, fourth. And then you have got score. So the first two column, customer ID and score. Now I just scroll down. Now here, if you see, the values are continuous. If I ask you, what is the customer ID and what is the value of score for this particular record which I have selected? In this case, the customer ID is C14935 and the score is 357. The data is given to you in a fixed width format. In a fixed width format, what happens is each column has a fixed width. So the first column has got a fixed width of 6. Now the first customer ID C1, if you see, the value is just 2 characters, but the width overall is 6 characters. If the value is less than the width assigned to it, the remaining thing is filled by empty spaces. And starting position and the ending position, the start position and the end position of each column is fixed. So the starting position of score is from 7th column and the end position is the 9th column. So in a fixed width format, what is very important to know is for a particular column from where the value is going to start till where it is going to end, from where the next column is going to begin until where it is going to end, the third column from where it is going to start and where it is going to end. We need to know the start end of each column. Here the start of the cust ID is from first column till sixth, and 7, 8, 9 is for score. This format is called a fixed width format. We'll now import this in Python. So here we are importing that file which I just showed you. I have to specify the specifications of the column. So here note, this is a rectangular bracket. The first column, it starts from index 0. because in Python index starts from 0, that's why I have to specify 0. Ends at 6. Basically 0 is the first column position, 1, 2, 3, 4, 5. The end number is not inclusive. Then 6 to 9, 6, 7, 8. Skip row equal to 1. The first row of the data had column names, but that row did not have the column names in this format, 0 to 6 and 6 to 9. As such, I am saying skip the first row. The moment I skip the first row, header is gone. And then names equal to, I am explicitly giving the column names, cust ID and score. If I run this piece of syntax, control enter, my data is imported, cust ID, score. How we can import a SAS dataset? There is a read underscore SAS function, and using this syntax, you just pass a SAS dataset and you can import it. We can import data from database. There is a package called SQL Alchemy. To import that, import data from a database, we can use SQL Alchemy. And having imported the package SQL Alchemy, I'm not going to execute this code because I don't have a database, but I'm just at a broad high level explaining the syntax. What you can do is from SQL Alchemy, import the create engine. Whenever you import data from a database, the way it works is you have to first open a connection to database. To open a database connection, you need to know the name of the database on which you would like to open the connection, what is the user ID, and what is the password. Now this database is hosted on what server, so you have to specify the server IP, and probably you will also have to specify the port. Okay, because when database listens, they listen on a port. Once you are able to create the connection, you can fetch all the table names using engine.table names. Here I have created a connection. That connection, I name it as engine. It is just like connecting from one mobile phone to another. To connect from one mobile to another, you need to know the number of the person to whom you want to speak. Here, besides just knowing the server IP and the port, you also require authentication, which is user ID and password. And once you have connected, you can execute commands. You can run a select query, you can run insert, you can update, all of those. So you open a connection. Remember, whenever you work on database, having opened a connection, you should close the connection. Typically, just as I said, when you connect to someone on a mobile phone, finally you have to disconnect. So similarly, in database, once you connect, then you can start running insert, update, delete. Basically, you can select data from database, you can insert data into a database, you can update, modify records, existing records, and having done whatever activities, you have to say connection close. This is how typically you work with a database. As I mentioned, we don't have a database connection. As such, I'm not executing. Broad outline how to connect to database has been explained. So far, what we have learned is how to go about importing data from various data sources. And as I mentioned, once you have imported data from various data sources, you would have done certain activities, data manipulation, and the next time you work, you would not like to repeat all the steps. You would like to store your data on a hard disk. How to store the objects which are there in your memory onto hard disk? Now, let me see what all objects are there in my memory. Just in case I want to know what all objects are there, percentage who underscore ls. I have been executing various codes. What all objects I have created? These are the certain objects. npospd. npospd are NumPy operating system and PD. I'm not interested in these, but still they will all get referred as certain object name. We created LRDF1, DF2, DF3, align dataset, and so forth. So this is a syntax to list all objects in memory which you have created. Now from this, I would like to store LRDF1, 2, 3 to hard disk. Okay. So how do I go about doing it? To store that, the syntax is, the package to be used is Pickle. Just like we make pickle, that is achar, I import the package Pickle. OS, I have already done OS. So if you have already executed, good. If you have not, then you can rerun it. Open, what I am now doing, this open function is, I am opening a stream to hard disk. Open is a function where I am saying open a stream to a hard disk, and where I want to save some content on a hard disk by the file name lrdf_1.obj. You can give any name, abc.obj. obj stands for object. obj stands for object. You can give any name. I have chosen lr_df_1. The stream which I am opening from memory to hard disk, I am saying the mode of which I am opening is write binary. Okay. Now basically what I am saying is, I want to store the content on hard disk in a binary format. That is, I want to serialize my data to hard disk. There is a technical term which you can offline search, serialization. I am trying to serialize my data to hard disk. For that, I am opening a connection to hard drive. Now what I want to write, I'm using a pickle package and I'm saying pickle.dump. Where should I dump and what should I dump? I am saying I want to dump LRDF1, one of the object which is in my memory. This object which is in my memory, I want to dump. Where? File write. File write is a handle to this file which is going to get created on the hard drive. Once I have written LRDF1 content to hard drive, if I don't want to write any more thing in this file, I need to close that handle. Just like in a database I mentioned, you have to open a connection and a close. Similarly, when you open a connection to hard drive for writing some content on a file, you open it, you write the content, finally you have to close. If you don't close, till that time the content will not get saved. So you can assume close is equivalent to saying save. Once I run this syntax, what will happen is, in my DK2 analytics data file folder, an object with this name will get created. Control enter. I have executed the code. I'll now show my folder. I have opened my folder. Here you can see DK2 analytics data file, and here LR underscore DF1 object date, today's date with timestamp. So this is the file which we created. Let me quickly run the second syntax also. Now here, once again, I'm opening a connection using file write, open. I've given the same name. You can give same name or you can give any name, because this name is just a variable name which we are using in Python code. This is not the name of the file which we are creating. The name of the file which we are creating is this. So here I'm now once again opening a connection. I've just given it name LRDF2 and 3. The reason why I have given 2 and 3 is because I want to write two files, the LRDF2, LRDF3. What mode in which I'm opening the connection? I'm opening it in write binary. If I want to read a file, I would have said read binary, but I want to write. That's why I'm saying write binary. Now I call pickle.dump. I'm saying dump the content LRDF2 in this handle file write. This handle points to this object. Then once again I say dump file write. What I'm doing is I'll comment this close. I'm not saving it. I'll run this later. So probably what I can do is I'll delete this, cut it, and below enter, I'll write it here. I'm running only this much part of the syntax. Control enter. The code is executed. I'll now show you my folder. I'm now showing you my folder. If you see size is 0 KB. Reason is I've said two files to be written. However, I've not closed the connection. As I mentioned, when you close means save. I execute the syntax. The moment I execute, the file size 894 KB. So this is how you save your content to hard drive. Finding objects in memory, percentage who ls, we have already executed this syntax, percentage who ls. I can once again run it. These are my objects. There is another function, percentage who s. If I run it, then it gives me more detailed information of each and every objects in our memory. Because Python does data processing in memory, we also require somehow can I delete objects from memory. Python being in memory processing, if you keep using memory more and more, then it may so happen probably it may give you an error, insufficient memory. So what I want is, can I delete objects which I don't want from memory? So here I have already saved LRDF1, DF2 and DF3. So I can delete those objects by saying del, which we already saw in our previous sessions. Del is a function, del is a syntax, not a function. Del is a syntax for deleting objects from memory. So del LRDF1, del LRDF2, del LRDF3, I've written 3 separate rows. Control enter. All of those objects will go off from my memory. Once again, if I now see percentage who ls, this time it does not show the 3 objects df1, df2, df3, lr, df3. And also note the rectangular brackets which you have open and close, which means the output of this is actually a list. In case I want to delete all objects, we can use a loop, because the output of percentage who ls is a list. List is a iterable. So what I can do is I can capture this entire output in a variable, and because list is a iterable, I can iterate through each and every object and run a del function on each and every of those objects in a loop. I remove this, control enter, and now if I see, so here this is a variable which we just created and this is the variable which we created, only those two are present. So at the end, if you run del val also and run it, in that case it becomes empty. This is just to show you how to delete all objects. The objective is not to go more programming. What is more important? How I can delete objects from memory. You can delete objects from memory using del syntax. So quickly execute these three records, these three syntaxes to delete lr underscore df1, 2, and 3, and check whether they have got deleted. I have got a clean slate. It's like I've just started my Jupyter notebook. Okay. I have certain objects which are stored in my hard drive, and I want to start my work on those objects. How do I load them? So what I can do is I can use Pickle, import Pickle. Now I will also have to do import Pandas, OS, and other steps. Reason being, when I run percentage %whols, you see all of the packages which we had imported, those are also not getting listed. So I'll just go up and quickly run import pandas numpy os, control enter, come back here. Okay, I need to set my directory also. I've set my directory also, and I come down. Otherwise, if I continuously execute the syntax without having imported those OS and other things, I would get this kind of error, OS is not defined. So let me just cut this. Shortcut is X, and here I'll just press V. os.get current working directory. Okay, my current working directory is now dk2 analytics data file. This is the folder where I had stored lrdf1 object. I import Pickle. I am going to open a connection to this file which is existing in my hard drive. Now the mode in which I am going to open is read binary. Technically, this step is called as deserialization. I put that term. You can go and do Google search. This is a technical term. When I wrote the data in a binary format, we call it serialization. When we read the data from a binary format, we call it deserialization. So I'm reading this content from this file in a read binary mode. So I say df1, I can give any name to the data set, data frame. What I had written, the name was lr underscore df1. While reading, I can give any other variable name also. It's okay. So I call it df1 pickle.load. Initially the syntax was pickle.dump. This time I'm not dumping. This time I am taking the data from dump. So I'm loading the data from dump. Pickle.load from this object, load whatever is the content in this. I load it, assign it to a variable by the name df1, control enter. OS, PD, all of that we created. Pickle is what we import pickle we did. File read I created, and df1. So these are the objects. So df1 is my data frame. I want to check the content. I can say df1.head. This is the content. So this is how you can load a data from a data frame. Let us now continue with this second object. In this second object, we had stored two data frames. Here, if you note, I should technically do one more step, dot close. Once you have opened a connection, you should close the connection as a good practice. In case you don't close the connection, the moment you open a new connection, the previous connection will get closed. But however, as a good practice, I'll close it. File read dot close. Now I'm now opening a connection to this object in a read binary format, and then I'll say pickle.load from this object. This file read is a handle to this object on the hard drive. So I'll say load. I'll read the content. I'm storing it in df_2. I'm running the syntax once again, dot load. I store the content in df_3. Here I can run the load syntax 2 times because I had stored 2 objects. The sequence in which you store the objects, in the same sequence you get the objects. Basically, it is FIFO. FIFO stands for first in, first out. Okay, so the sequence in which you store the data, in the same sequence you can retrieve the content from the object file. I have not yet executed the close syntax after opening the connection here. I am now trying to run the load once again. The moment I run the load, control enter, it gives me an error, ran out of input. Reason is, in this object file, there were only 2 objects. Here we had dumped 2 data frame, and those 2 data frames I have retrieved using the load function by executing it 2 times. The third time I execute it, it says ran out of input because there is no more object in that dump file. Best practice, once again, when you have completed your reading process, Control C, I'll just copy this. You should close the connection. I've closed it. I'll see %whols, df1, df2, df3, the 3 objects which we had pickled using the dump function, we have loaded using the load function. So quickly try the syntax for loading pickled objects. Okay, we have almost come to the end of our session. We have learned how to import We have learned how to save a data frame to a hard drive. We have learned how to load it, pickle.dump, pickle.load. We have learned how to get data from an external source. Now, the data in Python is in a Python format, Python object format. What if I want to give this processed data from Python to some other data management tool, and that data management tool cannot directly read a Python object? One of the standard data sharing format is comma separated values. There are various ways in which you can dump data to a file format, and the other tool can then consume that data from that file format. Here I'm just explaining a very basic export, which is a CSV, and the syntax is simple. df1 is my pandas data frame object. In that we have a function toCSV. This object is of type pandas. As such, all the functions which are available in pandas can be used directly by prefixing df1 dot. Okay, so here I say df1 dot toCSV, where I would like to dump. I would like to dump in a temp out folder by the name lrdf1.csv. What is this dot indicating? This dot is indicating the current working directory. What is my current working directory? This is my current working directory, dk2 analytics data file. So dk2 analytics data file, in that folder, data file folder, there will be another folder temp out, and in that folder I want to dump it here. Note, the folder should exist beforehand. It is not going to create the folder, it is just going to create the file. If this folder is not existing, in that case what you can do is delete it and directly write it dot slash lrdf1.csv. In this case what will happen, it will go in my dk2 analytics data file, and because I'm dumping it in the default working directory, I need not even write this. However, I keep my input and my output folders separate. As a best practice, I never mix input and output when I work on any client project also. As such, I will create a separate folder. Index equal to false. What I'm saying is, by default, whenever you see a data frame, this additional row index gets created. I don't want this row index to be going in the output, so I'm saying index equal to false. Control enter. Let me show the folder. This is my data file folder. What I'll do is dot temp out. In this folder there is another folder temp out. I come here, date modified lrdf1.csv with the current timestamp. This file we have just created. I can open this file in a notepad. Right click, open with notepad, and this is the content of the data file. So this is how you can export. So what we have learned: import, export, save, load. With this, we complete today's session. Thank you. See you in the upcoming session. Bye bye.